Multiplying binomials. In this lesson, we'll learn to multiply binomials. Let's revisit what we learned in science. If you look at this example, this will look very familiar to you. Punnett squares are used to show possible ways that genes can combine at fertilization. So in a Punnett square, dominant genes are shown with capital letters, recessive genes are shown with lowercase of the same letter. The Punnett square below represents a cross between two hybrid tall pea plants. A hybrid trait is a result of a combination of a dominant and a recessive gene. Parent plants are tall because the dominant trait masks the recessive trait. Okay? Letters representing the parent's genes are placed on the outer sides of the Punnett square. Letters inside the boxes of the square show possible gene combinations for their offspring. So if you take a look at this example, this was Mendel's pea plant experiment. Okay, and when you talk about the Punnett square indicates the genes, okay, or the alleles of a hybrid tall plant. A hybrid tall plant simply means that it has an allele of a tall pea plant and an allele of a short pea plant, and that's the same thing with the other gene. Okay, they're both hybrid tall pea plants where T is recessive and capital T is dominant. And if you recall, recessive means the trait that is hidden. Dominant is a trait that is being shown. Okay, so if you look at these two, and if you look at the Punnett square, okay, the Punnett square clearly shows that if you have two tall alleles, okay, the combination would be uh, capital T, and when you have capital T, lowercase t, you'll have this combination, and you have lowercase t and capital T, you'll have this combination, capital T, lowercase t, and when you have lowercase t and lowercase t, you will have two lowercase t's. Okay, so in this case, in this particular case, you have one short pea plant and three tall pea plants. Okay, where two of the three tall pea plants are hybrid pea plants, and one is true breeding. Okay, true breeding simply means that they both have dominant alleles. Okay, dominant traits. Okay, going back to our example, going back to math now. If we let T represent the dominant gene for tallness and T represent the recessive gene for shortness, when the parents' genes are combined, you see all the possible combinations of genes in offspring. Okay. Now, if we make this into an algebraic expression, this now becomes capital T plus lowercase t multiplied by capital T plus lowercase t. Remember also in our lesson on multiplying polynomial, okay, when you have a polynomial, basically what you are asking to do is find the area of a rectangle, and let's say this is our rectangle, okay, and if that is our rectangle right there, okay, that's a rectangle. Let me bring this down. Right there, let me close that up. That's our rectangle. That means capital T plus lowercase t will be our length. Capital T lowercase t will be our width. Okay, so let's go back to our example right here. So basically we're trying to multiply capital T lowercase t, which is the length and the width. What we're trying to do is multiply length and width to be able to find the area, and this should be the area. Okay, so if you look at it carefully, capital T plus lowercase t times capital T plus lowercase t will give us one capital T right there. One capital T lowercase t, one capital T lowercase t. So these are the two, and both lowercase t's. And if you combine a capital T and lowercase t, okay, and they're like terms, we can add them to become 2 capital T lowercase t. Okay, so this would be the product, okay, of, okay, that would be the product of capital T plus lowercase t times capital T plus lowercase t. Okay? Now, how do we use this now to multiply binomials? Let's find out. You have now capital T plus lowercase t. Capital T plus lowercase t is a good example of the product of two binomials. Algebra tiles can also be used to help you understand how to multiply binomials. Consider the binomial x plus 3 and x plus 2. To multiply these binomials, mark off a rectangle on the product mat that has dimensions x plus 3 and x plus 2. Then fill in the rectangle with the algebra tiles. What does that mean? Okay, let's find out. This is what it means. You have now x plus 3, which is the length of a rectangle, and x plus 2 would be the width of a rectangle. Now, if you notice, when we do this, this now becomes length x right here. Okay, that would be length x, and that would be length x. Okay, and if we multiply x times x, that will give us x squared. Okay, let me make that more permanent. Let's use red. So that is length x, and this is length x. Multiply length x together, we get x squared. And if you recall too, that in our x tile, this side would be the length, which is x, and that side would be the width, which is going to be 1. And these are both 1, and that's the reason why it's x plus 2. Okay, same manner, okay, that would be the width, and that's the reason why this is x plus 3. Okay, and if you look closely, if I multiply 1 times 1, or sorry, let's go through here first. If I get x and multiply it by 1, I'll get x right there. If I get this x multiplied by that 1, I'll get x. Multiply x and multiply it by that 1, I'll get x. And this is also following the Punnett square example. Going down here, if I get 1 multiplied by the width x, I will get area of x. 1 times x again will give me the area of x. And these are all now unit tiles, because 1 times 1 will give me 1. 1 times 1 will be another 1, and so on and so forth until it forms my rectangle. Okay, so what do we notice? If we use algebra tiles to multiply these two binomials, x plus 3 plus x plus 2, the product would be the area of this rectangle. Okay, and the area of that rectangle would be, before we do that, let's do this. Okay, x squared, that's x squared, and there are 5 x tiles, 1, 2, 3, 4, 5 x tiles, and there are 6 unit tiles, 1, 2, 3, 4, 5, 6. Combine them all and simplify them, you have x squared plus 5x plus 6. Okay, that is using algebra tiles to be able to multiply x plus 3 and x plus 2. Okay, now how do we multiply the quantity x plus 3 times the quantity x plus 2 using the area formula? So remember that the area formula for rectangle is length times width, and that's the reason why we multiply the quantity x plus 3 with the quantity x plus 2. If you look at this example, okay, the product of x plus 3, x plus 2 represents the area of a rectangle. We already know that. The area is also the sum of the areas of algebra tiles x squared plus 5x plus 6. Therefore, okay, x plus 3 times x plus 2 equals x squared plus 5x plus 6. So what it's saying is this. Okay, it's simply saying that if we use the algebra tiles and we let x plus 3 become the length and x plus 2 become the width, okay, we simply create a rectangle and we get this area. Okay, but there's another way of finding the product of x plus 3 plus x plus 2 without using algebra tiles. Again, algebra tiles become quite impractical when the coefficients of our variables become larger. Okay, let's take a look at this example. You can also use the distributive property to multiply binomials, and this is the keyword, distributive property. Okay, so using distributive property, we can multiply our binomials, 2x plus 3 times 3x plus 5. Let's do that using distributive property. Let's copy the problem down, 2x plus 3 times 3x plus 5, all of course in quantity. Okay, so first thing we need to do is distribute the 3x to 2x plus 3 and distribute 5 to 2x plus 3. Basically what we did was this. We simply got the 3x and distributed it to 2x and 3. That's why we got this. And we got 5 and distributed to 2x plus 3. That's why we got this. Okay? Simplifying that, we now have 2x times 3x. Okay? 3 times 3x. 2x times 5, 3 times 5. Okay? Again, we distributed 3x to 2x, 3x to 3, 5 to 2x, and 5 to 3. Simplify this further, so not that one, right here in the middle. Okay? You now have 6x squared, because 2 times 3 is 6. X times x is x squared. 9x, because 3 times 3 is 9. Okay, and you have 10x, 2 times 5x is 10x, and 15. And then we simply add our like terms. Like terms would be 9x and 10x, which gives us 19x. Okay, so the product of 2x plus 3 times the quantity 3x plus 5 is equal to 6x squared plus 19x plus 15. Okay, let's go back to our original example, or the original method that Gregor Mendel was able to discover by using Punnett squares. Okay, let's use Punnett squares to be able to multiply these two binomials. Okay, first let's create a Punnett square. Okay, create a Punnett square right here. Let me make that bigger. So let's create our Punnett square. Okay. I'll help me make it straight. Since we're multiplying binomials or two terms, we make a 2 by 2 Punnett square. Okay, and let's get what we are trying to multiply. We're getting 2x plus 3. So I'll put 2x plus 3 here. Okay, and let's get 3x plus 5. 3x plus 5. Okay, if you notice, I am writing the operation before the number, so we know if it's positive or negative. So in this case, we know that if it's 3x plus 5, it's positive 5. If it's 2x plus 3, it's positive 3. Okay, going back to what Gregor Mendel did. Okay, let's start our multiplication. If we multiply 3x times 2x, we put our answer here. That would be, let me make it blue, 6x squared right here. And if we get 3x multiplied by 3, that will be 9x. We get 5 multiplied by 2x, that will be 10x. And if we get 5 multiplied by positive 3, that would be 15. Okay? In this Punnett square, there is another step to be able to complete the process. And that is by adding the diagonal. The diagonal, if you notice, contains the like terms. So this diagonal oval that I just made contains my like terms, which is 19x. So what do? I simply get what's in my Punnett square, which is 6x squared. I add what's inside the diagonal, which is 19x. And I add 15. So using the Punnett square, we are able to multiply 2x plus 3 times 3x plus 5. Both methods work. It's up to you which method you find a lot easier to work with. Okay? Let's continue. Let's say you have 2x plus 1 times 5x minus 3. How do we do this using the distributive property? Again, we copy the problem down. 2x plus 1 times 5x minus 3. So if we look at this one, and let's continue using the distributive property now, you have 5x times 2x plus 1, negative 3. Remember, the operation before the number is the sign of the number. So that's a negative 3 being multiplied to 2x plus 1 using distributive property. Okay? Again, using that property, we simply distribute the 5x to 2x and the 5x to 1, which gives us 2x times 5x, 1 times 5x. And then we multiply negative 3 times 2x, and we multiply negative 3 times 1. Simplify that further, we have 10x squared plus 5x minus 6x minus 3. Add your like terms. 5x minus 6x is simply x. So the simplified form is 10x squared minus x minus 3 by combining like terms. Okay, let's go back to our Punnett square method and let's see how this works. Using the Punnett square, we have 2x plus 1, 5x minus 3. Okay, first let's create our Punnett square. Make our Punnett square. There you go. Okay, so let's write our two terms, our two expressions. So we have 2x plus 1, put it on top. Again, put the operation before the number so you know if it's positive or negative. And you have 5x minus 3. Okay, so having that one, let's solve this using the Punnett square method. Okay, we know that we have 5x times 2x will give us 10x squared. And if we have 5x multiplied by 1, that'll give us 5x. If I get 2x multiplied by negative 3, that'll be give me negative 6x. And if I have negative 3, multiply that by 1, that'll give me negative 3. Again, okay, group your like terms by looking for the diagonal. Okay, and after that, simply write out the product. Bring down 10x squared. Add what's in the diagonal. Negative 6x plus 5x is negative x. And simply bring down negative 3. And this is the way to solve or to get the product of 2x plus 1 times 5x minus 3 using the Punnett square method. Okay? Last one. I think that's the last one. Let's check. Yep, that's the last one. A rectangular garden is 5 feet longer than twice its width. It has a sidewalk 3 feet wide on 2 of its sides. The area of the sidewalk is 213 square feet. Find the dimensions of the garden. Okay, remember this problem because I think this type of problem may also come out on the test. Okay, so a rectangular garden is 5 feet longer than twice its width. It has a sidewalk 3 feet wide on 2 sides of its 2 of its sides. The area of the sidewalk is 213 square feet. Find the dimensions of the garden. It's going to be very difficult for us to understand this problem if we cannot visualize what we're talking about. So let's just use algebra tiles to model the situation. If we let x represent the width of the garden, okay, then 2x plus 5 represents the length of the garden. How did we come up with this? Because it says, okay, a rectangular garden is 5 feet longer than twice its width. 5 feet longer is plus 5, twice its width is 2x. And since x is our width, it is 2x plus 5. So this is how our rectangular garden will look like. This is the one right here. This is basically our rectangular garden. Okay? It has a sidewalk 3 feet wide and 2 width sides. That means, okay, 3 feet wide on 2 width sides on the right and the bottom. Obviously, you don't have a sidewalk at the back or on the other side too. So the sidewalk will be in this general area right here and in this general area right there. Okay, that's where the sidewalk should be. Okay, so what does that mean, 3 feet wide on 2 sides? It simply means that this becomes now your garden right here. Or sorry, this becomes your sidewalk. Okay, so this is now your sidewalk, 3 feet wide right here. Okay, 3 feet wide right on this direction. How do we know it's 3 feet wide? Because that's 1, 1, and 1. Remember, that's an X tile. Okay, so the length is X, the width is 1, and this is also 1, 1, and 1. Okay, and that now becomes, okay, our sidewalk right here. Right in that direction will be our sidewalk. Okay, so in our small rectangle, this is our rectangular garden. Okay, it has a length of 2x plus 5. It has a width of simply x. This now becomes our bigger rectangle right here. Okay, and if you notice, the length of our bigger rectangle is 2x plus 8. Why did it become 2x plus 8? Since now it's 3 feet longer, you simply add 3 units to 5, and that's why it became 8. And since this is 3 units, the width now becomes 3 units bigger. Okay, you add 3 units to x, that's why it becomes x plus 3. So remember this, you have a small rectangle and a big rectangle. Okay, let's find out what we need to do with that one. So if we want to get the area of our small rectangle, which is our garden, okay, it'll be x times 2x plus 5. Logical, right? Area equals length times width. And if we want to find the area of our big rectangle, okay, it's going to be x plus 3 times 2x plus 8. X plus 3 times the quantity 2x plus 8. Okay, now how do we plan to solve this? To be able to solve this, remember what we did in the past. Okay, what we did in the past was to be able to get the area of the shaded region, we need to get the area of the big rectangle minus the area of the small rectangle, and that's exactly what we plan to do. Okay, to be able to find the area of our garden and our sidewalk, we need to get the area of our big rectangle. This now becomes the area of our big rectangle. Okay, why did that become thick? Let's make that thinner. Area of our big rectangle is right here. Oops. Okay, and this becomes the area of our small rectangle, and this becomes the area of our shaded region. Remember this? Hope you do. So what we did before was that we got the area of our big rectangle, so we subtracted the area of our small rectangle to get the area of our shaded region. Okay, and this is exactly what we're going to do with our problem. So the area of our garden is x plus 3 times the quantity 2x plus 8. We need to subtract the area of our small rectangle, which is the area of our garden, which is x times 2x plus 5. Did I say area of my garden? Sorry. This is the area of the garden and the sidewalk, the bigger rectangle, x plus 3 times 2x plus 8, minus just the area of the garden, which is simply x times 2x plus 5. And it is given that the area of the sidewalk is 213. Okay, it's given right here, 213 square feet. Okay, going back to our problem. Okay, let's solve. Let's multiply the quantity x plus 3 times the quantity 2x plus 8. Okay, using the distributive property or counting tiles, whichever you want to do. I'd rather do the distributive property. You now have 2x squared plus 6x plus 8x plus 24, okay, minus 2x squared minus 5x, okay. You distribute negative x to 2x, distribute negative x to negative 5. Remember what we talked about, okay? The operation before the number in addition or subtraction is always the sign of the number. So this is actually negative x. Multiplying it to 2x will give you negative 2x squared. And if you multiply it by 5, it will give you negative 5x. That's why it's negative, okay? On the x plus 3 times 2x plus 8, we used a Punnett square. Let's make use of a Punnett square, smaller Punnett square this time. Oopsie. Let's get that out of the way. Okay. Here's my Punnett square. Make use of that smaller Punnett square. Okay. You have x plus 3 and 2x. Sorry, I'm on the wrong pen here. Okay. X plus 3 and we make that red. Now it's red. 2x plus 8. Okay. 2x times x will give us 2x squared. 2x times 3 will give us 6x. X times 8 will give us 8x. And 8 times 3 will give us 24. Again, remember our diagonal. We circle our diagonal because those are our like terms. And simply bring everything down. You have 2x squared. 8x plus 6x will give us 14x. And bring down 24. And that's how you got this trinomial right here. Okay? And after that, we simply combine our like terms, okay, using the commutative property of addition. Okay? You have 2x squared minus 2x. You're basically getting this one and that one. Okay, plus 6x plus 8x minus 5x. Those are all our like terms. Okay, this is simply 0. Okay, and you have 6x plus 8x minus 5x will give us 9x. Or if we can make this 14x, sorry, I forgot the x here. If I make this 14x and subtract 5x, I get 9x. So it's the same thing. Now I have 9x and bring down 24. Okay, we subtract 24 to both sides of our equation. Okay, so this now becomes a two-step equation. Okay, subtract 24 to both sides, end up with 9x equals 189. And then to be able to solve for x, we simply divide both sides by 9, end up with x equals 21. Okay, the value of x is 21. The width of the garden is 21 feet. And the length is 2x plus 5. So we simply substitute 21 to our x, okay, end up with 47 feet, which simply means that our garden is, okay, our garden is 21 feet by 47 feet. What remains to be done is simply checking our answer. If we get 21 feet for our width and 47 feet for our length of the garden, let's see how this works. If the total area of our small garden, which is 24 times 50, okay, and we want to subtract 21 times 47. Why is it 24 times 50? Because now we're looking at this whole thing, x plus 3 times 2x plus 8. Okay, that's the reason why it's 24, because x plus 3. That's the reason why it's 50, because this is 2 times 21 plus 8. 2 times 21 is 42 plus 8 is 50. There's the area of the garden and the sidewalk. Subtract it with the area of the garden, which is 21 times 7, 213. Is it equal to 213? Is 1200 minus 13, 1200 minus 987 equal to 213? The answer is yes. And our answer is correct. Okay? And that's how you multiply binomials, and that's also how you solve word problems using multiplication of binomials. As promised, that was the last example. And on Google Forms, type the summary of what you've learned by responding to the objectives of the lesson. Objective or objectives. Oh, there's only one objective. And type a question you might want to ask in class. Okay? Thank you.